Hello and welcome to UiPath Advanced Training Orchestrator. In this tutorial, we'll show you how UiPath Orchestrator works as the command center for robots and workflows, providing management capabilities for large deployments of robots and complex processes spanning multiple machines and human reviewers. Let's take a look at how to operate multiple robots, deploy processes, and monitor them. You should already be familiar with UiPath workflows, activity properties, and passing variables between activities. So, if you're ready, let's begin. We'll start our example with 3 robots. One of them is installed on the local machine, while the other 2 are installed remotely. First, let's see how to deploy and trigger a process. We'll go ahead and publish this package from Studio. It's a fairly simple workflow which opens the Notepad application and types "Hello UiPath Orchestrator." From Setup, we'll click Publish, which will send the package to Orchestrator. A confirmation window pops up, displaying the name and the version of the published package. In order to run a workflow on multiple robots at the same time, we need to group the robots together. So going back to Orchestrator, we will create an environment for the 3 robots we want to use. To create this type of robot collection, we'll go to the Environments page and click Create Environment. We need to fill in the name, type and description, and then assign each of the aforementioned robots to the environment. Next, to easily run the package on all the robots available in our newly created environment, we have to pair the 2 components. Now, this pairing is done by creating a process from the Processes page. We'll select the Open and Type Notepad package published earlier and select the version. As you can see, there is only one version of this package available, as it's only been published once. When a project is published more than once, multiple versions of packages will be displayed. To complete the process creation, we simply need to select the TOEnv environment, and that's it. Now, using this process, we can trigger the execution of the same package on all 3 robots at the same time. Now, to do this, we need to start a job. From the Jobs page, let's click Start Job. We'll select the previously created process, open and type notepad_TOEnv, select all the robots and click Start. We'll give it a minute there. And, as you can see, the execution has completed successfully on all 3 robots. Now let's check the robot machines. The robot running on the local machine has opened Notepad and typed "Hello UiPath Orchestrator." We should find the same on the other 2 robots. Let's quickly connect. And as you can see, we have the same result on the first and on the second remote machine. With this short example, you've seen just how easy it is to develop a workflow on a machine and then deploy and execute it on multiple robots from other machines. Now let's take a more in-depth look at the UiPath Orchestrator capabilities. First things first, let's take a look at the Orchestrator UI. On the left-hand side, we have a navigation panel that enables us to easily go through all available functionalities. On the top right corner, there's the User menu with links to Settings, Users, Audit, and the Logout button. Clicking on the UiPath logo will take us to the Dashboard page, where information about all Orchestrator components is displayed in chart form. We can see different statistics here, such as the status of all the registered robots and the transaction status evolution over a specific amount of time. Establishing a connection between a robot and Orchestrator requires 2 steps. First, we need to provision the robot in Orchestrator. And second, we need to configure the robot with the necessary information from Orchestrator. For the first step, we'll need to go to the robot settings. These can be accessed from the system tray, clicking the UiPath robot icon, then Advanced, and Settings. From here, we'll copy the machine name and paste it to Orchestrator. We'll add the robot name and the Windows credentials, which are required in order to run unattended jobs, and we're done with the first step. We can click Provision. Before doing that, we'll quickly copy the robot key as we need it for the second step. Now, going back to the robot settings window, we simply need to paste the robot key, add the Orchestrator URL, and hit OK. And we're done. Configuration completed successfully. Let's check the robot status. Here it is. The heartbeat was sent a few seconds ago, which means that everything went smooth. Being able to see the heartbeat of the robot is extremely helpful, as it will help immediately let you know when something might be wrong. For example, this robot is not responding. The last time it sent a heartbeat to Orchestrator was 2 months ago. Additional investigations might be needed here. Okay, now that we have seen how to set up the connection between a robot and Orchestrator, let's take a look at how we can trigger the robot. Now there are two options here. We can either do it remotely from Orchestrator or locally from the UiPath Robot System tray panel. For the second option, we will again click on the UiPath robot icon in the system tray, navigate to Available, and trigger the desired process. And that's it. Let's recap. To manage and start processes with UiPath Orchestrator, you have to follow a couple of steps. First, register your robot or robots with Orchestrator. Publish a project from UiPath Studio. Create an environment containing the robots that you want to use. Create a process with a published package and the previously created environment. And finally, start a job that is an execution of the process. Now let's see how we can manage different versions of the same package. We've made a small change to the workflow used earlier so that it now adds a new line in Notepad that writes "end of file" before finishing the job. We'll go back to the Setup tab and click Publish again. A new version of this process has been published. Let's go to Orchestrator and check this. From the Processes page, we'll click View Packages and search for our workflow. Hit Refresh and then click Versions. As expected, there are now 2 versions available for this package, the one that we published at the beginning of the exercise and then the second one, published just seconds ago. Now what's important to notice is that even though there is a new version published, the robots are still configured to run the old one. To change that, we need to update the process. Going back to Processes, let's search for our process and here it is. This icon tells us that updates are available. We'll click Manage Versions and update to the latest version available. Now, let's start the job again and test to see the changes. This time, all the robots should execute the latest version of the package. There you go. End of file. Now, in case something goes wrong, you can always roll back the process to the previously used version with a click of the button. Aside from displaying the versions, the Packages page also enables us to do the versions maintenance. We can use the delete button to remove any of the package versions, provided they're not currently in use. If we only want to keep the current used version and remove any old and unused versions of a package, the delete inactive button can be used. If you choose this option, one thing to keep in mind is that if none of the package versions are assigned to a process, they will all be deleted from Orchestrator. Until now, you've seen how to start a job from UiPath Orchestrator manually. However, the real power comes from being able to schedule these jobs to run at different time intervals. For now, let's do a quick example scheduling the execution of our job on all the robots from the associated environment every minute. After 1 minute, the job is automatically executed on the local machine as well as on the 2 remote machines. If we wait 1 more minute, the job execution will be triggered again. Great! Schedules can be manually disabled and enabled with ease. Additionally, when they're not required anymore, you can simply delete them. Now let's talk a bit about the scheduling options. From the Schedules page, we'll click Add Schedule and select the Open and Type Notepad process. Now, there are a couple of scheduling options available. We can choose when to trigger this process. We can set it to run every X minutes, hourly, daily, weekly, or monthly. We can also choose to stop the process after a specified amount of time. In the Execution Target tab, we have the option to schedule the process to run on all the robots, only on certain robots, or we can configure it to run on a specified number of robots. In this last case, the orchestrator will do the assignment. Now let's go back to the Jobs page and take a look at the source column. As you can see, there are 2 possible values here. Manual, when a job has been triggered manually from the Start Job window. Schedule, when a job has been triggered by an active schedule. Now, what happens when a robot is already executing a process and a schedule is triggered? In this case, the triggered job will be placed in a queue in pending status and will only start once the machine becomes available. We can place multiple jobs in a queue, and they will all be executed in order, one after the other, regardless of whether they were manually started or triggered by a schedule. To showcase this, we'll use a really simple workflow that displays a message box with the "Click OK to finish this job" text. We've already published this package, so it's available in Orchestrator. We'll start this process first, simple message box. And then the Open and Type Notepad process. Now, as you can see, the first job is executed keeping the local robot busy, while the second is placed in a pending state. When we close the message box, the execution of the first process finishes with success, and the pending job starts running. The Jobs page also offers 2 buttons for stopping the execution of a workflow: Terminate and Cancel. The Terminate button kills the execution of a job, regardless of the automation step the robot was at. The Cancel button works a bit differently, as it's used along with the Should Stop activity. When you click the Cancel button, the workflow will continue to run until it reaches the Should Stop. This activity enables us to safely stop a workflow and should always be placed at key steps. If you do not cancel the job, the should stop activity is not triggered and the workflow continues to run. Let's see how this works, step by step. We'll start our message box process. And after it starts running, we'll click the Terminate button. A force stop command is sent to the robot, and, as you can see, the execution is terminated. The message box has disappeared. Now let's test the Cancel button. We've already modified the workflow by adding the should stop activity. This activity returns a Boolean. Usually it would return false, but if we choose to cancel the job, it will return true. By taking a decision right after this activity, we can choose what the robot should do at the end of the process. Now, if we do not cancel the execution, the robot will write "Hello UiPath Orchestrator." If we do cancel the job, the robot will write "End of file" in Notepad and then end the process. Let's quickly update to the latest version of the package and run the process using the updated workflow. As you can see, the robot is now writing one row at a time in Notepad. If we terminate this job, its status will change to cancelled. The file is still opened and the writing ended when we click Terminate. Let's run the workflow again and this time click Cancel. As you can see, the job is executed until the robot types "End of file." Alright, let's move on to the monitoring feature. UiPath Orchestrator has the ability to monitor all the robots registered to it, and it provides access to all the messages logged by robots through the Logs page. For example, this message was logged by one of the robots used for our process. If we click Details, we can see further information, such as the message, timestamp, logging level, or version of the package. By default, the logging level of a robot is set to information. This means that if everything goes well, the robot logs in when the execution starts and when the process ends. We can change the logging level from the robot settings. To get a better understanding of how logs work, we've once more modified our process to include 5 different messages if the job gets cancelled. We've set a different level of logging for each activity: trace, information, warning, error, and fatal. Now let's run the process and cancel the execution to see what are the logs messages that the robot will send. If we go to the logs page, you'll notice that only 4 out of 5 logs are displayed. The trace message is missing. This is because the logging level for this robot is set to information. All the levels which are lower than that will be skipped. Since trace is lower than information, it will not be displayed here. If we set the logging level for the robot to errors and run the same job again, we can see that the robot has logged only 2 messages, the fatal and the error ones. The other 3 levels have been skipped. Now, in terms of customization, the add log fields activity allows us to add new arguments to the log structure by using a collection of arguments. Let's change the workflow again to see how this works. We will use a variable to count the number of rows typed by the robot in Notepad. For the add log fields activity, we'll need the Notepad line number argument and we'll set the counter variable as the default value. Let's run the process again and then cancel it. Now, if we go to the logs page and click details, you'll notice that a new line is displayed at the bottom of the log message with the argument we just created. Great! Now that we've seen how logs work, let's move on to another useful feature that Orchestrator holds for us. Let's talk about assets. Assets provide a simplified and centralized way of managing variable values within a workflow. They can be used like a type of global variables that can be shared by different machines, environments, for synchronization and data management purposes. Any variable from a workflow can be synchronized using an asset. Let's go back to our Notepad example. Suppose a developer has created this workflow, but is not sure about the information that should be typed in Notepad. A second person from the testing team has this information and can use the workflow to perform the tests. Now, there are 2 available options here. The difficult way, the tester will manually edit the workflow in UiPath Studio, publish it to Orchestrator, update the process it's a part of, and finally start the updated workflow. Or the easy way, the tester can edit the value of an asset in Orchestrator, and when the robot executes the workflow, it will automatically use the updated asset value. And that's it. So let's go to the Assets page and create a new asset. We'll use our example, so let's name it Notepad Text. Next, we need to set the type of value that we'll store in this asset. We can choose between text, boolean, integer, and credential. In our case, we'll select text and type Hello UiPath in the value field. Now, we'll go back to our workflow and change it to request the asset value. The getAsset activity comes in handy as it extracts the value of an indicated asset and outputs it as a variable. Let's also replace the hard-coded text with the output variable from the getAsset activity. The workflow can now be saved and published. We have to update the process to the latest version and run the job from Orchestrator. all 3 robots have started executing the job. If we hit cancel, you'll notice that all the robots have been typing hello UiPath, the value that we assigned when we created the asset. Now suppose we want the robots to type something else. We simply need to edit the asset created earlier and enter a different value. Say, hello world. Let's trigger the job again and see what we've got. Look at that. Hello world. Wait, there's more. Suppose we want each robot to type a different thing. We can do that by specifying different values for each robot. We'll edit the Notepad text asset again, and this time we'll select the per robot option. We will select the robots one by one, and we'll use their names as the value that each of them is going to type. Let's run the process again and check the results. As you've seen, we have used the same process with the same asset on multiple robots. Yet, with a minor change at the assets level, each robot has typed a different message in the Notepad application. Assets can also be used for storing credentials. In this case, we'll have to provide 2 values, a username and a password. Also, we need to replace the getAsset activity in our workflow with the getCredential activity, which, as you can see, has 2 outputs, the username and the password. Moving on to the next topic, let's discuss about the Orchestrator queues. The queues are designed to store lists of items that have to be processed by multiple robots. For example, when you're dealing with a large list of records and you want to make sure that there are no duplicates in the results, using queues is an excellent solution. Say you've got an Excel file with a high number of rows, or maybe a ton of emails that you need to process. Both scenarios make very good candidates for Orchestrator queues. To explain this better, we'll use 2 workflows. The first one will read the values from an Excel file and add them to a queue. Alright, the robot has finished the job. Now let's take a look at the details section for the used queue. As you can see, each item has 3 arguments, each with a specific value. Let's use our 3 robots to process these transactions. Each robot will take a different item from the Orchestrator queue and will enter the values in our demo application. Please note that one of our robots has the application closed and will not be able to process transactions. We've already published the package for processing the queue transactions, so now we need to create a process. Let's start the job and select all 3 robots. The execution is triggered, and now all the robots have started working like a team, splitting the tasks dynamically. Once the job has ended, we can switch to the transactions page and analyze the status of all the items that have been processed from the queue. Let's add a filter to see only the failed items from the queue. It looks like there are 2 of them. We can use the Details button to check what happened. In this case, for example, we have a business exception with the reason these are not numbers. Now let's go over the available statuses that the items in a queue can have. When a new item is added to a queue, it is automatically added with the new status. As soon as the item is sent to a robot, the status changes to In Progress. Once the transaction has been processed, the status can change to either Successful or Failed. Now the failed status can have 2 types of errors: Application or Business. If the Auto Retry property of the queue is enabled, the orchestrator will resend the item to the robot for reprocessing. In this case, the item status will change to Retried. Finally, if an item stays in progress in the queue and it is not processed within 24 hours, its status will automatically update to Abandoned. Now let's take a step back and understand how this example was created. We started by creating the demo queue in Orchestrator. Now this is pretty straightforward, as we only added the name and enabled the Auto Retry option. As mentioned earlier, when a transaction fails with an application exception and this option is enabled, the orchestrator resends the item to the robots as many times as the maximum number of retries field specifies it. Now in UiPath Studio, we used 3 activities for queue processing. First, the Add Queue Item activity, for adding an item with the status new to a specified queue. For this activity, the queue name and the priority properties are mandatory. This is because the items will be sent to the robots for processing based on their priority. The defer date and due date properties enable you to add a time frame for processing the queue items. Suppose an item must be processed in maximum 24 hours. We'll use due date for this. And that it must be processed no earlier than 2 hours, we'll use defer date for that. Alright, the second activity used is Get Transaction Item for requesting an item from the specified queue. There are 2 mandatory properties for this activity: the queue name and the transaction item as the output. When this activity is placed in a loop, it iterates through all the items in the indicated queue. The third activity, Set Transaction Status, is used to update the status of the processed items to failed or successful. Keep in mind that if the status of an item is not updated by the robot within 24 hours, it will be automatically changed to Abandoned. As input for our process, the following Excel was used. The robot would have to read the whole file and for each row, add a new item in the previously created queue. Each item would contain 3 arguments, 1 for each of the 3 columns with values from the Excel file. We used only 1 robot here to avoid having duplicates in the queue. Now, let's see how the second workflow was created. We started with the Get Transaction Item activity. Now this activity requests an item from the queue. If there are no new items and no items to retry in the queue, the getTransactionItem activity returns a null value. So this is something that we need to check. If that's the case and the robots reach the end of the queue, they will log a message. If there are new queue items available, we need to get the values and use them in our workflow. We'll store them in 3 variables using 3 assign activities. To access the value of an argument, we have to use the specific content parameter and specify the argument name. Since we're not sure what values are stored in the queue, we will use string values. The next step in our workflow is for the robot to check whether the extracted values are numbers. If the result is false, the transaction status will be set to failed with a business exception. If the values are integers, the robot will move to the next step to check whether the demo application is opened. If the application is closed, the transaction status will be failed, this time with an application exception. If the demo application is opened, the robot will input the values and click the accept button. If all the steps are completed, the status for the current item is set to successful using the setTransactionStatus activity. For this activity to work as desired, we need to input the transaction item variable and select the proper status, successful, from the properties panel. Going back to Orchestrator, let's check the other processed items. As you can see, there are no failed items with application exception. This is because the items with an application exception have been retried, and the last time they were processed, they were successful. There are 3 manual statuses available only for the items that have failed with an application exception. The status in review informs other people in the team that this item is being checked. After the review is completed, you can manually retry the item or mark it as verified. One important thing to keep in mind is that once you have marked an item as verified, you can no longer manually retry it. And one more thing to add here, the postpone transaction item activity enables us to change the item, defer and due date. Suppose an item is sent to the robot but the environment is not ready to process it. In this case, using postpone transaction item, these 2 properties can be changed. Now let's go back to the queues page and check out the stats generated for our queue. This page displays the number of items that will need to be processed, the average execution time, the number of successful items, the application exceptions, and the business exceptions. Additionally, for each queue, a line chart is available so that we can easily see the transaction status evolution over a specific amount of time. Aside from the status report for robots and jobs, the Orchestrator dashboard also displays a line chart for all queue transactions. To have a better overview, we can go ahead and change the time filter to last hours, last day, last week, or last 30 days. Alright, well that pretty much covers it. To sum up, UiPath Orchestrator is a web application that enables you to manage all the resources at your disposal in an efficient manner. Business processes deployed to Orchestrator can be executed by multiple robots simultaneously, and they can also be scheduled to run at custom times. The Orchestrator platform facilitates the automation process and, together with Studio, streamlines the teamwork. Thank you for watching. Until next time.